Okay, so this is our second video dealing with Euler's line. In the last video, we talked about this idea of centers of a triangle. And we're given this triangle here. So in the last video, we graphed the triangle with these points, found the equations of the three altitudes. That's the lines that drop from the vertices. So if you have a triangle like this, for example, your altitudes are just lines that drop from each vertice over to the other side at a right angle. So that's what an altitude is. They drop from each vertice, and if you keep doing this over and over again, and they meet the other side at a right angle, they'll meet together at one point. And once we found the equations for those altitudes, we were able to find the point where they intersected, which is the orthocenter. I'm going to focus my energy here on this centroid, part C, and maybe circumcenter. We'll see how much time we have. So, I mean, just a quick glance, this was our part of our work from the last video, and notice that the orthocenter, it's a little sloppy here, sorry, but it's 6'2", and my point's a little off here. It should be down a little bit just because of the rough sketch. So I resketched it just for the sake of this video. Now I labeled the orthocenter O, and that point's right there, 6'2". And this is our rough sketch of the triangle. So now we're going to focus on centroid, right? The centroid of the triangle. Now the centroid is essentially, it's where the medians meet. And this center will be different than the orthocenter, right? That was where the altitudes met. So where do the medians meet? Well, the basic idea of a median, of course, is that it's at the halfway point of a line. So we can have three medians here, one on each side of the triangle, and they'll meet together at one point. That's our centroid. So let's approximate, and that's okay. We can always start by approximating. Where would the middle be on this right here between A and B, the midpoint? Well, we can use the midpoint formula to do that, I guess, instead of estimating. That probably makes more sense. So let's say, what is the M, the midpoint of AB? Right, so not slope M, but midpoint. And that's going to equal what? Well, how do we find midpoint? What do we do? Well, in general, what we do is we add up our x values, whatever we're given, and average them. Right, divide them by 2. We add up the y values, right, and average those. And that, in general, will give us a midpoint. So for AB, what's that going to be? Well, here's 0, 0, and 6, 12. So it's 0 plus 6, or 6 over 2. That's our x value. And then our y value will be 0 plus 12 over 2, so 12 over 2. We simplify this, we get 6 over 2, that's 3. And for 12 over 2, we get 6. So that's our first midpoint. 1, 2, 3, and then up 6, so about here. And we're on our way. Centroid is kind of nice because here, in the bottom line, for example, we don't really need the midpoint formula. Right, the midpoint of AC it's just the halfway point of a line. And this line is 10 units long because it goes from 0 up to 10 on the x-axis. So the midpoint will just be 5, 0, right? Half of 10. So 1, 2, 3, 4, 5. Now we're getting somewhere. And that's our second midpoint. So M, 5, 0. We'll call it M2. It's 5, 0. Well, you know what? I'm sorry. Call it M of AC. We'll be consistent here. That's what we just called it before. Is 5, 0. Right, equals 5, 0. And this is M of AB. And now we have the midpoint of AC, of BC next. So the midpoint of BC. So what do? Well, BC is right here. And we add up our x value. That's 10 and 6, or 16. Over 2 for our x values, we're averaging those, and our y values, 12 plus 0 over 2. So 12 over 2. So the midpoint on this side is going to be what? Well, 16 over 2 is 8, 12 over 2 is 6, and we have our midpoint, 8, 6. So here's 5, 6, 7, 8, and then up 6. 1, 2, 3, 4, 5, 6. And there it is, midpoint of BC, and we're almost done now, is equal to 8 and 6. So now the centroid says, alright, well, to finish drawing these medians here, you have to connect them to their opposite vertice. So there's 1, Here's another, right? Oops, fell off there a little bit on the line. This line, this line is actually just a very, very steep slope in comparison to the others. Having a hard time drawing that. Try one more time. This slope is almost vertical, but it's got to connect to this vertex up here. So let's see if I can get this time. Better. Okay. And then one more to go. And actually, I didn't do that bad of a job drawing it, surprisingly. Oh, of course, there. Fell apart. Try one time. Alright, close enough. So this is going to be our centroid. Of course, you want to find the exact value of it. So part of the approach, I think, should be to find the equations of these lines. So let's start with this midpoint line right here, or this median, excuse me. This line right here is going to cross through this median, AC. That's a 5, 0. So that's 1 point, and it has to cross through B over here, which is 6, 12. So let's find the slope of this median. Let's just call it median 1. So I'm running out of room and names here. So median, capital M, 1. What does that equal? Well, again, we know we have to find the slope of that median. Now I'm using slope. This is how I delta y over delta x. That's our slope. I want to find that, the median. So subtract our y values. 12 minus 0 is 12. 6 minus 5, right, is 1. So the slope of this line is just 12 over 1, or 12. And we know the points on this line, 5, 0, and 6, 12. So if I want to find an equation for it, I can say what? Well, y would have to equal 12x as our slope plus b. What's b? Well, let's go back a second here. Instead of x, let's use 5, 0, this point. 12 times 5, that x value, plus b, has to equal 0. Right? If you think about the form y equals mx plus b, this is saying, hey, plug in an x value, in this case 5, and you get this y value. That's all I'm doing here. I'm plugging this x value to get that y value. If I don't know the y-intercept, I don't know what that is. Let me just go a little bit. Okay, I can't. The y-intercept is what we're trying to find out, right? So let me just drag this over so you can see it. There it is. Move it over so you're working with me. Okay. So now, I'm solving for b. 12 times 5 is 60. So what plus 60 is 0? So that's negative 60, right? Solve for b, we get negative 60. So it turns out the equation for this line right here, for M1, for that median, should equal 12x, the slope, right, plus negative 60. That's our first line. Now our second line, let's call it M2, so we have M1 right here. Let's call this line M2. What do we know with that? Well, we know the y-intercept is at 0 again. And if we find the slope, we just do delta y over delta x. So for M2, the delta y over delta x, what does that equal? What's the slope? Well, 6 minus 0 over 8 minus 0, or 6 over 8. If we reduce that, of course, we get 3 over 4. And this is nice because this equation will be just 3/4 x. Right? The y-intercept is 0. And now we've got one more line to deal with, M3, and then we're done with the centroid, really. M3, should be this line right here. This one might seem a little trickier, but again, it is very closely related to the first one, the first median. This median, of course, has a delta y and x. So we solve that first. I like to do that first. We can do 6 minus 0 over 3 minus 10. So that's 6 over what? Well, 3 minus 10 is what? That's negative 7. So this line has a slope of negative 6 over 7. And we want to find the y-intercept so I can write my slope in y-intercept slope form, or slope-intercept form. And again, I'm going to pick a point that's easy to work with, and point C is on this line, right? And it tells me that the x value has to be 10, and the y value should be 0 at that point. So y equals mx plus b, y is 0, equals m, this is our slope, negative 6/7, x plus something equals 0. But we already know what x is. X is 10 at this point, so it's negative 6 over 7 times 10 plus something gives you 0. Simplifying a little bit, we get 0 equals negative 60 over 7, plus b, and that equals 0, so b has to equal positive 60 over 7. That's our b value. So our equation here for this line is what? Well, that's negative 60 over negative 6/7, excuse me, the slope, times x plus 60 over 7. So we have these three equations for three medians, and the centroid will meet at all of them. Here's one, right? Here's the other equation, and one more, and here it is. So again, you know, this might seem difficult here, but we can deal with this, right? We can find the centroid. All we have to do is set these equations equal to each other and solve for x. So I'm going to choose to set these two equal to each other. And my reasoning is that I don't need to set all three equal to each other. If two of them cross at, right, if two of them cross at a point, we know the definition of a centroid is that the third median has to also cross at the same point. So by setting two of them equal to each other, we can just solve for x, get our x value, and then find our y value, and we're done. So I'm going to choose these two because they seem easier to work with. So we're going to say that the median 1 equals median 2. Right? That's our assumption here. We're going to find when that happens. So when does that happen? Well, median 1 is 12x minus 60, and that equals 3/4 x. So we just now solve for x. We'll multiply everything by 4. Right? I want to get rid of that fraction. So 12x times 4 is 48x. Right? Minus 60 times 4 is, that's 240, equals what? Well, 3/4 times 4 is just 3x. And now it's just simple manipulation of this problem, but I'm running out of room. So let me just use this space up here. Okay, so what do we do? Well, I'm going to add 240 to both sides, and I get 48x equals, well, since I'm running out of room, sorry, I'll do this in one step. I'll subtract 3x from both sides and add 240 to both sides. So 3x on both sides, that'll give me what? Well, 48x minus 3x is 45x. Add 240 to both sides, and that equals 240. So now we set this up and we do 240 divided by 45, which, if you work it out, we'll get 5 1/3. Right? Or x is equal to 16 over 3, however you want to write that. I think I refer to myself 5 1/3. And that gives us the x value of the centroid, right? And it looks like it too. I got it pretty close. Here's 5 1/3. So our 5 1/3, what's the y value? Well, again, these lines are all meeting at that point. So I'm going to choose this equation for this line because I think this will be easiest to work with, right? It's just one short equation. By plugging in the x value here into this equation, we can find the y value at that point. So really, and this is nice actually, all this complicated stuff reduces down to the simple equation. When I plug it into the second median equation, m2, which equals 3/4 times x, in this case 3/4 times 16 over 3. Right? That's a wonderful thing to work out because these 3's cancel out, and 16 over 4 is just what? Well, 16 over 4 is 4. So when x equals 16/3, y has to equal 4. And that's our centroid, right? So our centroid is equal to 5 1/3 and 4. And we're almost there. We've got our orthocenter, we've got our centroid. We're going to go into the next video, and the next one we're finally going to finish up this problem, right? Got the orthocenter, got the centroid. Next we're going to tackle the circumcenter, and then talk about how all this ties together with the awesome concept of Euler's line. Alright, thanks.